Okay, now in this model, first we'll go to okay. So for this now we will have one cross arm this side. Okay, at this point. So here first we'll select node cursor. So using node cursor we will select the node at this point and here at this point. So these points we will transfer in this direction. Oh sorry, we don't want this point right now. We'll just deselect it and we want cross arm of 5 meter at this point. So only for those points we'll make a translation repeat for 5 meter in x direction with a linking of step. Okay, so point it is there. Now we'll create midpoint there. So for that first we'll select the beam cursor. This beam it is selected, right click, insert node and add midpoint. Okay, so midpoint it is inserted here. Now we'll join the points here this way. So for that we will do, first we'll click on isometric view. We'll just rotate the structure. Okay, so that the points will be visible. Now in this we'll add the beam from this point here and here. Okay, now one more thing that we will do here, that is we'll create a midpoint for these two inclined members, this one, and then we will join to the another node. So we have created the midpoints here. Okay, let us zoom this so that we will get a clear view. And now using add beam we'll join these points. This way. Okay, so one side cross arm it is completed. You can see this cross arm in a clear view. Okay. Now same cross arm we will repeat on another side. So for that we need to use the mirror command. So first we'll select the front view. Only the cross arm members we will select and we'll check in isometric view whether all are selected or not. Okay, in this direction. But for that first we need a one plane here, a symmetrical plane here. So for that first deselect this and let's create one midpoint here. So to create a midpoint of this section, you need to have the diagonal here. So for that we will create a one temporary member using add beam and we'll just join the diagonal here. So using this diagonal and creating a midpoint for this diagonal using insert node, add midpoint. Okay, so here that point it is created. Okay, so about this point we will have the mirror command. So for that let us make it to whole structure. In this diagram again we will select all these cross arm points, total cross arm members this way. Okay, all are selected. Now we have to use the mirror command so that this cross arm it is repeated this direction. Okay, it will be copied this direction. So first we have selected all these members. For that we have created this additional node here. So now in geometry, selecting this mirror command. Now in this mirror command, our plane, it is YZ plane. About this YZ plane we want the mirror image. So YZ, it is by default selected. Now we will select the node about which we need to have the mirror command. We need to repeat it. So we'll select this node and we'll select this node. Okay, we want to copy the structure, not to move the structure, so we'll keep this copy option as it is and let's say OK. So see, this mirror command, it is repeated here. Okay, so our structure, it is completed. Now we will apply properties to this structure. So let's create the properties. Geometry is completed. Now properties. So in property, for this all members we need to apply a standard double angle section, back to back double angle section. So that we will create through the standard. Select the Indian code, Indian sections, angle unequal section. Let us assume certain higher angle section, for example 200 by 150 by 15 with short leg back to back. Okay, we are selecting this short leg back to back double angle section of ISA 200 by 150 by 15. Add, and for all remaining members we will assign one more section with a single section. For example, let us assume 130 by 65 by 10. Okay, let's add it and close it. So these two properties that we have created. First property that we need to assign to the column members, and except column for all remaining members is 135. So first select the first property, that is double angle. So for that, just change the view, this direction, that is front view, and select these column members. Okay, manually we will select these column members, all column members for which we need to apply the property. Okay, now let us check all these points in isometric. See here, bracings are also selected. So for that you need to deselect the bracing first. So we'll change the view, that is this side view, and just will deselect it by clicking the center point here. Okay, center of bracing, so that it will get deselected, because the property that we have selected double angle, that we need to apply to only column members, four corner members. Okay, so this way we have selected the property, and now we need to simply assign to selected beams. Assign yes. Okay, it is assigned. Now for all remaining points, now this property, it is assigned to this member. For remaining all members, in order to select all those remaining members, for which we have to apply this another property 135 by 65 by 10. So for that we will select all members through missing attribute property. So missing attribute, missing property. So here only those members will get selected which are not assigned any property. Okay, so all members are selected, property it is selected, assign to selected beam and assign. Okay, so here our property selection, it is completed. That can be checked in 3D rendering view. Okay, so here it is 3D render view. All properties are assigned there. Okay, now material by default it is selected steel. We do not have any specification here. So now we'll assign the support at these four corners as a fixed support. So first let's create the fixed support. So create this fixed, add, select this fixed support. Now only select the node points at this point. So for that, first using a node cursor, select the bottom nodes. Use control key and select the second node. check in isometric view that all 4 points are selected and assigned to selected nodes. So that property it is assigned here. Now loading. So this transmission tower it is subjected to mainly dead load. So first we will add a dead load here. Let us give the title dead load, add, close. So under this dead load mainly we have to add the self weight. So here along with the self weight we will be adding certain more 10% load that will be encountered for live load as well as the bolt connection, gusset plate, etc. So we will add a factor of minus 1.1, add, close, and just assign it to assign to view. Okay, so this dead load it is assigned here. Now another load that we need to create it is wind load. So select the type, it is wind load, give the title WL wind load, add, close. So for this wind load definition, first in order to create this wind load, first step it is to create the wind definition, that is to identify the wind intensity. So for that we'll go in definition, wind definition, let's say add, select the code here IS 875 part 315, add and close. So just click on this type 1 wind, add. So here we need to define the intensity versus height. So intensity we will use a shortcut method of STAAD PRO. For that we need to select the code that is already selected. We'll just click on this generate button. So in this generate button we have to calculate the design wind pressure. So here it's a 3-page calculation are given. So first page the common information it is given. So select the structure type, lattice tower, maximum height, that code has by default taken. Height interval it is also given there. City, select the Nasik city, for which right now we will assume the K1 factor 1, K2 factor as per the code it has calculated all these values. K3, K4 factor right now assume 1, 1. Accordingly just click on OK. So here it has defined that intensity versus height table. Click on add and it will ask for exposure factor. So let us take exposure factor 1. Click on add and close. So intensity it is added here, exposure it is also added, but exposure need to define. So this exposure you assign to total structure, that is assigned to view method. Okay. Okay. So it is assigned there. Now under wind load we will create that intensity. We will apply that intensity in positive x direction with a factor of 1, add, in x windward phase but with a negative factor minus 1, add, similarly in z direction with a positive factor 1 and negative factor minus 1. Okay, add and close. So here that wind load it is assigned. Okay, wind load it is assigned. Here you can create the different titles, that is wind x plus, wind x minus, wind z plus and wind z minus. So it will, you need to add that in a separate title. Here I have added all 4 cases under same load. Now after dead load, live load and wind load it is added. Now we will create the load combination. So for that we'll use again the STAAD PRO editor, that is auto load combination. Select the IS code IS 456800 and the load combination category, that is IS 800 2007 table. IS 800 2007 table 4. So here we'll generate those load combination. Okay, so all load combinations are generated. Click on add, close. So you can see all load combinations are automatically added here under load case details. Now the total geometry, assigning the property, supports, loading, it is done. So now last job it is to run the analysis. For that we'll use the define command, that is perform analysis all, add, close and simply run the analysis. Okay, so here it is analysis is completed. Fine. Now we'll design this structure. So for the design of transmission tower, you need to define the parameter, that is FYLD, which is for mild steel we are using the 250 Newton per mm square. So that's in kilonewton per meter square. Add and close and assign it to total structure. Okay. Now in commands, use check code, member takeoff and steel takeoff. Just add these 3 points and assign it to total structure. Okay. Assign to view, yes. Steel takeoff, assign to view, assign yes. Okay, so all properties are assigned now. So now simply run the analysis. You have selected the code. First you need to check the code. It is IS 800 2007 LSD, and then use this all commands. So now simply run the analysis. You will get the design confirm. Later on you can check all points in post processing. It's reading the results. Okay, design it is completed. So now in post processing, here you can check for any particular combination the what are the load results. So right now we will assume for all load combinations, apply OK. So here is the deflected shape. Okay, deflected shape of the transmission tower subjected to wind load. From this you can select the primary load case under dead load. This is the deflection. Under wind load, this is the deflection. Or under all load combination, this way is the deflection of the transmission tower. Okay, now we'll check the SFD diagram. This is the shear force diagram. Here is the bending moment diagram. We'll change the scale using control and just moving the mouse wheel. This is bending moment diagram. These are the beam stresses, compressive tensile stresses. Okay. Animation also you can check. Animation in a deflection. Simply apply OK. So this is the deflection of transmission tower animation. Okay. And now we'll see reaction, support reactions, beam results. That is the same thing that we have seen right now. And last one, it is utilization ratio. Okay, so here is the utilization ratio. Okay, in output file you can check which load, which member it is pass, which member it is fail. Okay, for example, we'll click on this member 137. So it is pass, member 137. For the critical load case number 1, its location it is given, and slenderness ratio, that is whether it is a tension member or compression member. Similarly, for all members it is given here. Okay, when you generate a report, there it will give you the total summary as per the member 1 to last member, it is member number 160. And steel takeoff, it gives you the total quantity, that is the two properties that we have, that is short leg back to back ISA section 200 by 150 by 15. Total length it is 201 and weight it is 156, and this next one it is given. In member takeoff you get as per the member. Okay, so here it is completed.